Hello and welcome. Today I'm solving my puzzle Magic Square Kropki. The rules are ordinary Sudoku and Kropki rules, and somewhere in the grid there is a magic square of 9 digits without repeats. Ordinary Kropki rules are that digits on a white dot are consecutive, digits across a black dot, one is double the other. The magic square is basically a 3x3 region without any repeats. I'll show you on this blank grid. Imagine that's a magic square. Each of these rows and each of these columns sum to the same number. There are 9 digits. The total of the 9 digits is 45. 1/3 of that is 15. So each of these rows, columns, and also the diagonals sum to 15. If you graph out the possible ways to get to 15, if you have a 1, you have a 7, no, you have a 1, 6, 7, a 1, 6, 8, and a 1, 9, 5. If you have a 2, 2 can go with 6, 7. No, that's not. Yeah, that is true. 8, 5, 9, 4. The 5 can go with a 1, 9, 2, 8, 3, 7, and 4, 6. And from that, you know that this has to be the 5 to go with 4 different pairs. If you were to graph this out completely, you would see that the odds, besides the 5, the odds all have 2 possible pairs, and the evens all have 3 possible pairs. The 5 goes there, and the odds go on the sides where they have their 2 possible pairs. And the evens go in the corners. So that is the basic magic square. This can be rotated and flipped as long as the evens are in the corners and the 2 and the 8 are across from each other. That will add up to 15. The 4 and the 6 are across from each other. They will add up to 15 with the 5. The odds, the 1 goes with the 6 and the 8. The 3 goes with the, what does the 3 go? The 4 and the 8. The 7, of course, goes with the 2 and 6. And the 9 goes with the 2 and 4. In a Kropki puzzle, we know that all the digits on the black dots are 1, 2, 3, 4, 6, 8, and there's never a 5 on a black Kropki dot. Therefore, we know that none of these black dots can be the 5 that is at the center of the magic square in this puzzle. We also know the center of the magic square can't be on the perimeter. Kind of redundant to gray that out, but just to give you a visual of where the magic square can't be. Magic square center can also not be on one of the white dots because, as we said, the 5 is in the center and it's got odds on its edges. It's connected orthogonally to odds. So on a white dot, 1 is odd and 1 is even. So these can't be 2 odds. It can't be the center of the magic square. None of these can be. And then we have digits that are beside a black dot. This black dot, well, let's see. In order to be on the side of a magic square, you have to go even, odd, even. So if there's a black dot there, it is an even, odd pair. The only even, odd pairs are 1, 2, and 3, 6. Those are even, odd pairs that are on black dots. 1 and 2, 3 and 6. Now, if the 5 were here, and that's a 1 and a 2, that would have to be a 12. And that wouldn't work because 12 is not a Sudoku number. If it were not 1 and 2, it would have to be 3 and 6. This would have to be the 3 and not the 6. And then this becomes a 6, which is summed to 15. And you can't have two 6s in a column. Nowhere in a cell adjacent to a black dot can the center of the magic square be. So all these places next to black dots, next to cells that are on black dots, cannot be the 5 at the center of the magic square. This cannot be the 5. If that were the 5, these 3 have to sum to 15, and they're consecutive. The only 3 consecutive digits that sum to 15 are 4, 5, and 6, and that would be a 5, and that would be 2 5s in a row. That's not the center of the magic square. None of these are the center of the magic square because they are next to a white dot that is in a column with 2 black dots. In a column, in the black dots, 1, 2, 3, 4, 5, or 4, 6, 8, they either contain 2 evens or 1 even and 1 odd. There's already 2 evens in these 2 white dots. These 2 black dots contain the other 2 evens. So those 2 black dots contain 1 odd each. They are 1, 2, and 3, 6. The white dots, one of them is the 4, 5 pair, and the other is an 8 with either a 7 or a 9. This is a 7, 9 in this column. Now, if this is the 5 to be the center of the magic square, that can't be the 4, 5. It is either the 7, 8 or the 8, 9. And either way, it's too many to form a sum of 15 with one of these 2 cells. This cannot be the 7, 8. It cannot be the 8, 9. 8, 9 is 17. 7, 8 is 15. None of these are the center of the magic square. The center of the magic square is there. That is a 5. One of those is a 5. This is either a 3, 4 or a 6, 7. Those are the only pairs that go along the side of a magic square that are consecutive. 3, 4 doesn't work because this is a 1, 2, 3, 4, 6, 8 possible candidates. And if that's a 3, 4 pair, then these are not 3, 6, or 4, 8. They're both 1, 2. Take the 3, 4 out of there. Make that a 6, 7. 6 and 7 sum to 12 or 13. And you have to add a 2. So there's a 2 there or a 2 here. But if the 2 is there, we end up with the same problem as we did with the 3, 4 here. A 2 there and the 6 there means that these are not 1, 2 or 3, 6. They're both 4, 8. That cannot be the 2. That cannot be the center of the magic square. That is the center. That's 7. There's a 3 over there, a 6 here, and a 4 down here. That makes a 2 there, an 8 there, a 1 there, and a 9 there. And we have our magic square located in the grid. This is not an 8 or any digit consecutive to 8. It's a 4 or 5. These are not the 4 or 5 pair. That 4 needs a 2 or an 8, but the 8 makes that a 2. These are not 2 or 6. So they're not a 3. The 4, 8 pair makes that the 1. This 1, 5, 9 makes this a 2, 3, 4 or a 6, 7, 8. The odd one is in the middle, either a 3 or a 7. The external ones are the evens, 2, 4, 6, 8. This is whichever 3 these are, those 3 are the others. They are 2, 3, 4, 6, 7, 8. If the 2's not there, if these are 6, 7, 8, that's the 3, 4, and that's the 2, and that's never a 3, 4. If this is a 2, 3, 4, that 2, if this is a 2, 3, 4, this is a 6, 7, 8. The 6, 7 here makes that the 8. That is always a 2, 8. This cell is not 1, 2, or 3, 6, could be 2, 4, or 4, 8. Those are all the evens in that box. These are the 3, 9 pair. There's an 8 here and an 8 here. That forms what's called an X-wing. If this is an 8, then that's an 8. And if this is an 8, then that's an 8. Either way, there are no other 8s in the row. This is a 1, 2, 3, 4, 6, but it can't be an 8 because of the X-wing I just mentioned. This is not the 1 or 2. This is not the 1 or 2. It's not the 1 anyway. This 2, 8 means that there's a 4 there. There's no 4s here. And that makes that a 3, 6 pair. Makes that the 9. I pencil marked that an 8 earlier. That was a 3, 9 pair. There's the 3. How did I get there? This is the 5, 9 pair. This is a 2, 4, 5, 7. But that 4 up there means that's not the 4. 5 here means that's not the 5. 1's here, put a 1 there. Not a 1 here. Not a 3 there. Not a 6 there, or a 2. Those are 3 evens. There needs to be an even on a white dot. There's a 6 down here. No 6 or 3 here. That's the 2. That's the 1. These are 6 and either 5 or 7. That makes this a 3 and the 6. This can be not a 1, can be a 2, 3, 4, 5, 7, 9. This is not a 3, 5, 6, or 7. 1, 2, 4, 5, 6, 7, 8, 9. This can't be the 9 because that can't be the 8. This is a 1, 2, 3, 4, 6, 8. But not a 2 or a 1 because of these two 2s. That's not the 4 or the 3 in the row. It's not a 6 or an 8. That's either a 3 or a 4. This is a 2, 3, 4, 5. And we can put 1, 2, 3, 4, 6, 8 here. This is not the 1. So, the X-wing of 8s, take the 8 out of there. If that is a 2, this is a 4. That becomes a 3 and a 6. And then what is this cell right there? Again, that's if this is a 2, that's a 4, that's a 3, then that is neither a 3, 2, or 4. And that 3 would make that a 5, and they are not consecutive. This is not a 2. Now, if this digit is a 6, that's an 8, and that's a 4, that's a 3. Then this is a 1, and that's a 2, but that's a 2. Again, 6, 7, 8, 4, 3, 2, 1, 2. This is not the 6. That is either the 2 or the 4, and this is a 3. 6, 8 out of there. This is the 8. These are not the 3, 4 or the 8. They were never the 8. Once I put the 8 up there. 6 and the 3, not the 6. 7 is consecutive to 6. Eight needs to be in this box. Goes there with the 4. This is the 8. That's not the 8. This is neither a 3 nor 4. That 8 takes the 8 out of there. 2, 4. This is a 5, 8. Now, if this is a well, this can't be a 3. It's either a 2, 6, or 8. If this is a 6, that's a 3, that's a 1 and a 2, and not a 2. This cannot be the 6. It's the 8, the 5, and the 8. 4, 5, not the 8. Not the 4, not the 8, or the 4, or the 5. Not the 7 or 9. One of these is even, it's the 2. This is the 6 and the 3. Not the 6. It is the 6. 3 down here by Sudoku with those 2. That's 3 in the corner. This is the 2 and the 1. 4 and the 2. 5 and the 4. This is a 1, 2, 3, 9, 7. Not the 3. Seven, 9 pair in the column. That 9 means a 9 down there, and a 7. Not the 7s, and that is the 7. So 4, 8, 9. Not the 4 or the 8. That's the 9, not the 9. This is a 1, 2, 3, 4, 5, 6, 7. Say 1, is it a 1, 2 pair? 2 there, 1 there. This is a 4, 5, 6. This cannot be the 1, because that cannot be the 2, because that 2. This is the 4 because of that 2. This is the 5 in the row and the 9. Last 2 digits, 1, 2, 3, 4, 5, 6, 7, 8. last four. 1, 2, 3, 4, 5. 1, 2, 4, 5. Not the twos, not the ones. That 7 makes this the 5. These are not the 5s. These are not the 4s. Last digit, 8. 7, 9, 4. I don't have a 4. I have too many 4s. What was that supposed to be? Oh, when I said 4, I missed in the column and made that a 7. Hope that's right. Need a 4 in this box. Goes there because of those two. 7, 9 pair. 7, 9 pair in the column. 1, 6, what, 5? Not the 1, not the 5. One 6 pair makes that the 5. Need a 3 in this box. Can't go next to a 7 on a white dot. 3 there. Puts a 3 there and a 9 there. Puts a, what does the 9 do? This is not a 5 or an 8. That's a 6, 7 pair. That's the 8, and the 7, the 8 and the 4, the 2 and the 4, the 5, because of the pair of 6s, the 6. That's a 1, because of the 6, 7 in the column, the 5 and the 1. That's a 6, and the 6, and the 7, and the 7, the 7, the 9, and the 6, and the 1, 7, and 9. Last two digits are a 2 and a 9. And that's it, 20 minutes. Hope you enjoyed it. Please go solve it on Logic Masters, and if you like it, please give it a rating. I really appreciate that. Only about a third of the people that solve my puzzles on Logic Masters give me a rating. And it makes my puzzles look less popular and less enjoyed, actually. So help me out and solve my puzzles and rate them. Thank you.